Hello and welcome back to Introduction to Physics Labs. My name is Paul Eric, and today we're going to be doing Lab 1.11a, which is entitled Rotational Motion. So in a previous lab we have talked about linear motion, either sideways motion or up and down motion, and so now we're going to be doing rotational motion. And so I've got these words here, and I just want you to know that whenever I refer to something as being linear, it's the same thing as translational, meaning sideways or up and down in a line. And then angular means that it's rotational. It's going around in a circle. So this word, it can be substituted for this word or vice versa, and then this one for this one. So we're going to be doing rotational motion, or we could say angular motion today. And so the purpose is to understand the concepts of angular distance, angular velocity, and angular acceleration. Then to be able to calculate the linear speed of a rotating object. And then to understand the concepts of torque and moment of inertia. And also then to know what Newton's second law of motion is for rotating systems. And then to observe the translational and rotational kinetic energy of a system, and then finally to actually be able to calculate mathematically the translational and rotational kinetic energy of a system. So under the procedure it says to go to PhET ladybug revolution, and then this is what you're going to see. Okay, then it says to click on rotation. So up here it says intro, and then next to it it says the word rotation. So go ahead and click on that, and then when you do, you're going to go to this. Okay, and so here's the live version of it. And notice this is a complicated simulation because you got all these graphs over here. You got different kinds of things that you can change here. You also have places where you start the simulation, where you end the simulation, and then you got all these different kinds of buttons. So we're going to kind of work our way through it and see how this simulation works. So it says to set the angular velocity to 30 degrees per second. Okay, so if we go back to here, we're going to set the angular velocity. So here it is, and we want to set it to 30. So we can just click on this and then type in 30. So that's going to be, now look at the units. The units are going to be in 30 degrees per second. So this tabletop over here is going to be rotating that fast. Okay, then the next thing it says is under show graphs, click on theta, omega, and then alpha. Now at this point you don't know what any of that stuff means. That's great. So don't worry about it. So just do what it says there. So under the show graphs, click on those three. So we want theta, omega, alpha, and we go over here, and then you can see it has, these are the various things here. So we want theta, omega, and then alpha. And so that's going to be this one right here. And then if you look, you see that it has theta, so that's the angle. It has omega, so that is going to be here. And then it has alpha down here at the bottom. So those are your different kinds of graphs. Okay, so now let's go back, and it says click on the red minus signs for the angular velocity and the angular acceleration versus time graphs. So we're going to go back to here, and we're going to click on the minus sign for this one, and then we're going to click on the minus sign for this one. Well, that looks much better. So now we're just looking at one of the graphs. Okay, now next thing that it says to do is when something is traveling sideways, linearly, translationally, the distance r is measured. So if you've got a ruler, the distance from here to here, maybe that's 30 centimeters. Okay, so that is a linear distance, which we give the letter r. Now, when something is rotating, however, we talk about the angle through which it rotates. So that if you have a tire, and then let's say the tire starts there, we could let it rotate through this angle right here. And so this is going to be theta. So theta is going to stand for an angle. So we're going to click on the go button and let the ladybug rotate through an angle of about 90 degrees. Okay, so that it doesn't have to be exactly perfect, but we're going to go back to here. We're going to hit the go button, and then we need to let the ladybug stop when he or she gets to about there. So as you can see, the angle isn't exactly perfect up here, but it should be close to 90 degrees. And then if you look here on the graph, you should notice that the angle in degrees started at 0. So right here, that would be 0 degrees. And then it rotated up to here, and so this was 90 degrees. So you should notice that on your graph. The official metric unit for angles is not the degree. So it's something called the radian. And so if you go around in a complete circle, that's called 1 rotation. It's also called 1 revolution if you go around in a complete circle. But you should know from geometry that that's 360 degrees. And you should know, or maybe you don't know, that that is 2 pi radian. So the radian is going to be the official metric unit for angles in the metric system, something that you're probably not so familiar with. 2 pi radians if you go around in a complete circle. And then pi is 3.14 ... because it's a number that doesn't repeat itself. It just goes on forever and ever. But if you go to 3 significant figures, use 3.14. So using the conversion factor, calculate the angle into radians. And so you're going to put your angle, whatever it was. So let's just say that it was 90 degrees. Okay, so you put 90 degrees for the measured angle in degrees. Now we need to calculate the angle in radians. So let me show you how to do that. So you're going to put down 2 sets of parentheses on your piece of scratch paper, which you've got with you right now. Get it? Okay, don't just let me do everything for you. So on your scratch piece of paper, you're going to write down 2 sets of parentheses. In the first parenthesis, you're going to write down what do you start with. So I'm going to say 90 degrees is what we're going to start with. And then the second set of parentheses is going to be your conversion factor. Now we're trying to get rid of the word degree. So that means the word degree has to go in the bottom of the fraction. So the one on the bottom is going to cancel the one on the top. Okay, now we're trying to get to radians, so we're going to put the word radian on the top. Okay, now we go to our conversion factor. Look at the number that is next to the word degree, and you see that it is 360. And then look at the number that is next to the word radian, and that is 2 pi. So in order to do this, now I'm not going to do it for you. I'm going to let you do it for yourself, but you're going to need to take 90 on your calculator times 2, so that's 180, times 3.14, so whatever that number is, and then divide by 360, and then hit equals, and then that's going to be your angle in radians. So you're going to put that number here. Okay, now we want to know if we did it correctly. So what we can do here is we're going to click on radians to see if we got our answer right. So let's go back to the simulation here, and we're going to click. You see here it says the word degree, and underneath it, it says the word radian. So click on the word radian, and you see that it changed this number up here. And so that is what the angle is going to be in radians. So on your chart here, you will have measured the angle in degrees, you will have calculated the angle in radians, and then when you click that button, write down what is the answer in radians, and then hopefully these two numbers are going to be the same. Okay, let's take a break. And so when we come back, we will discuss what do we mean by angular velocity.